So I would like to say it's like there were two ways to learn stuff. The smarter, of course, you learn it before the test, and you prepare for the test, and you do well on the test, right? So, um, and that happens. Now, sometimes you do fail a test. You do fail a test. You do not because you stop learning when you fail a test. No, you can choose to start learning after you fail a test as well. I think Alan, who else with you that day? Aiden. Okay, so Aiden and Alan, come in after school. They are the only two kids. I didn't ask them to say. They end up staying, go over the whole test. They find out what kind of mistake they make. They find out that they could have scored a lot higher than 66%, uh, which is that's what he got this time. So he went from a 30 to 40 to 39 to 42 and now to 66. And he could have gone higher. He could have gone like 70 or 80, I think. Um, but he's working towards it. That's the thing. The attitude is should not be like every time you fail a test you're gonna be depressed. No, every time you fail a test you should start learning at that point. You cannot just stop learning. Go back and say, hey, how do you do better? And that's why I like what Kobe Bryant says. He says, you know, he played a game to learn from it. He didn't play the game on the. They asked him the two perspective. Are you a player hate to lose, or you are just a player love to win? He says neither, because neither is the right attitude. Because he just played to learn the game, and there's a difference. Even he's the best player in the world, he still choose to learn from each game. Or you have the same mentality, or you have the same attitude towards that. And I think Alan does in this case. Hopefully, he will keep on improving. Hopefully, I don't want to see this learning stop. I want to see you grow from each test, even the test you did well or the test you didn't do well. Okay. Um, Another thing is I would like to tell you is you should always like a lot of time a lot of students afraid to say that something they did it wrong. Like especially I ask in the class, I'll ask somebody. So for example, it happened the second and third period. Is a lot of students ask them and they will be like, oh no, I didn't finish. Um, and they stop before they finish the problem because they're afraid that they afraid that they already did something wrong. You know what? If it's wrong, go all the way around. It's okay because right now is the moment that you can learn from each failure. In the test, it's not the time to learn. It's not the time to figure out how to get a right answer. But you should know how to get a right answer. But right now, it's okay for you to try all the things that you can possibly try, and then you move from that. Um, a lot of time like oh I didn't finish I feel like something is wrong and I didn't finish, or like question for example sometimes they know how to do question 1 to 10 on a homework, and then the first question 11 question they don't know how to do, then they don't do anything after 12. That's a problem. The problem is you have to finish the job and find out what you did wrong and go from there. Like you playing piano, anybody play piano here? Okay, so Jenny is the only one. So when you practice a song or piano, do you stop the first line you mess up? No, you play the whole song. You learn where you mess up throughout the whole song, and then you go back and redo it again and redo it again and redo it again. You go through all of them, right? Make a lot of mistake on all of them. That's fine. Go back and fix each one. So that's the correct attitude towards things. So learning, make sure you have the right attitude. Um, and this just not only in math, it actually it just it's in everything else. In basketball, right? You cannot just say, "Oh, first quarter I didn't do well. I'm not gonna play the next three quarters." It sounds like a lot of you guys right now. Like first quarter, I lose by 10 points, and you stop. So I give up. That's the mentality you guys have. So I feel like this generation doesn't have a strong mentality. You need to have a strong mentality in order to get through this class. All right, next, we're gonna talk about chain rule. Sorry. Oh, don't be afraid of being wrong. But You miss 100% of the shot you don't take, right? Chain rule. Now the funny thing is every time I say chain rule, people thought I say CHEN because I'm Chinese, like chain rule. Like how people make fun of Chinese people, like ching chang, whatever. So they say chain rule. No, no, it's chain rule. Okay. So why do we need to learn to take a derivative? Wait, Bennett, did you take a test?
Yeah, I took the test.
Okay. So what is a chain rule? What rule we already have learned on derivative, by the way? What we have learned so far? Power rule. Okay, we're gonna start with the power rule. So power rule is derivative of x to the n. Derivative of x to the n equal to nx to the n minus 1. And what else? Product rule. Okay, product rule. And we have learned also constant rule. What's derivative of constant? Derivative of constant is 0. And product rule is derivative of f of x times g of x. Now, today's rule is going to look kind of like this, but it's completely different. So this one's going to be f prime of x times g of x plus f of x times g prime of x. Okay, so that's product rule. So if I take a derivative of f of x times g of x, and you guys already know this, you don't need to copy down. And there's a quotient rule. And we're kind of going to talk about those two rules also while I'm at it. If I take a derivative of f of x over g of x is equal to low d high minus high d low, and don't forget about the low low. Right? Don't forget about that. So we have learned all those rules when we're taking derivative. But then what is chain rule? When do we use for, right? So when do we take a, chain rule is basically you use for derivative of a composite function. Does anybody know what composite function is? Yes. Thank you. Okay, so if I take a derivative of something like f of g of x, right? So what is that? So assume that I have a h of x is equal to f of g of x. So it's different than f of x times g of x. G of x is within f of x. So it's a composite function. So if I decide to take a derivative of this, I'm going to get a two-layer situation. I call it onion rule. Oops. The onion rule is first layer and the second layer. So if I take a derivative of this, it's going to be f prime, the derivative of the outer layer. So I'm going to use color code so that way you can see it. F prime of g of x times g prime of x. Derivative of the composite function, you start taking derivative of the outside. And you leave the inside alone, and then you take a derivative of the inside. Now it's like kind of like you peel onions. Onion is only like vegetable has layers, right? If you peel the onion from the outside, you still have inside still in there. It's not changing. Now you're gonna take a derivative of the inside, so you peel another layer and you go with the inner. So basically they are multiply each other, but they keep inside the same. Okay, but you just take a derivative of each layer, pretty much. Is it Jesus here? Okay.
Say it was like g of h of x, would it be f prime g of x, and then would it be f prime? How would you write that? Like,
well, yeah, we're gonna get there. We'll get that tomorrow when we got a inner of the inner function. So we got multiple layers. So we can have 3 layer, we can have 4 layer, especially in trig, we have multiple layers, but we'll get there. But right now, we only worry about 2 layers. Is that okay?
Yep.
Okay. So right now, let's first of all recognize what's a composite function. So let's just say if I have, if the h of x is equal to f of g of x. Now let's just say if h of x is equal to 2x minus 1 to the 4th power, what will be the f of x in this case, and what will be the g of x in this case? And let me ask like people like Neil. What do you think what's f of x is and what the g of x here? Neil? It's okay. Just even it's wrong, just go ahead and be wrong. It's okay.
What are you asking?
I'm asking if h of x is f of g of x, which is in this case they are equal to each other. So what will be the f of x and what will be the g of x here?
X 2x minus 1.
F of x is 2x minus 1. What is g of x?
The 4th power.
Okay. Anybody else is different? Alan?
G of x 2x minus 1 and x 3 power.
Now which one's right? Alan's right. Okay, sorry, Neil, but that's okay. Don't worry about being wrong. At least now you know. So this is the outer layer. This is something to the 4. So this is x to the 4. And if I plug in x as 2x minus 1, therefore this is 2x minus 1. So imagine that this within this, right? So would it be just parenthesis 2x minus 1 to the 4th? Does that make sense, Neil? Okay. And like I said, right now, I don't really care if you got it wrong. I care about you got it wrong on test. So right now, even you got it wrong, there's nothing embarrassing about it because you guys just first time learned this. Let's say h of x equal to root of 1 minus x squared. What will be the f of x and what will be the g of x here? Misha?
X. So for f of x, radical x.
Radical x?
And then for g of x, 1 minus x squared.
Perfect. Everybody okay here? Neil, you understand? Okay. Nizar, you understand? Did I pronounce your name right? Nizar? Nizar, sorry? Are you sure? Okay. I don't want to pronounce it wrong. Which is, I'm still getting Nelly wrong. You're white, that's fine.
Okay, that's racist.
We are live streaming.
I can down it.
Okay, how about sine of 6x? What will be f of x and what will be g of x here? Connor? What's f of x and what's g of x? F of x is sine of x, and what's g of x? 6x, good. Because you plug in 6x into the x, which is sine of 6x. Is that okay? Now, the remember, like, here's the general rules when you use chain rule. So general rule, we're not gonna use rule of thumb. So general rule that we're using chain rule is gonna be when you have parenthesis to the power other than 1. So the only times there's something parenthesis to the power other than 1, you should use chain rule. So now here we're gonna first take it the first derivative of this. So it'll be 2x minus 1 to the 4th power. So I want you to take a derivative of this. And I want you to try it and see what you get. If I try to take a derivative of this, Eli's done? Okay. Lian and Kadian, you guys gotta watch your video tonight and you guys have homework. Okay, I'm gonna show you how to do it. There's a first layer. Do you see that the first layer? Something x to the 4th power, would you say? And there's a second layer, which is 2x minus 1. So there are 2 onion layers. Just imagine those 2 layers. So we're going to take a derivative of the first layer. The first layer is something x to the 4th, right? We talk about that as the composite function, right? So therefore, y prime is going to be 4. The inside is still intact. Inside doesn't disappear. You don't take a derivative of inside, but the inside is still there because we want to take a derivative one at a time, one layer at a time. So to the 3rd power, and times the derivative of the inside. What's the derivative of the inside? 2. And then it's going to be 8 times 2x minus 1 to the 3rd power. That's it. Super easy.
You don't want to use your.
What?
You don't want to expand.
Oh, by the way, a lot of people try to be cute. It happened last period. They say, can I distribute the 8 into here? No, you cannot. Were you trying to think it like that? Yeah. Oh, no, don't need to expand. Now, here's why you don't need to expand the parentheses. So, for example, I want to find horizontal tangent. I already take the derivative, right? I just take the factor equal to 0. That's it. So x is equal to 1/2. Now, horizontal tangent is going to be x equal to 1/2. So it's much better to leave it factor form and you don't have to expand them. You don't need to expand them because factor form is better. Is this okay? You guys ready for the next one? Okay. So let's say y equal to 1 minus 2x squared to the 10th power. So I say, hey, can you take a derivative of this? And once you're done, check another friend you have. See what is it? Everybody done? Okay, there are 2 layers, right? There's a second layer as well. So the first layer is, I'm going to take a derivative of that. So it'll be y prime. It'll be 10, 1 minus 2x squared to the 9. Is that okay? And times derivative of the inside, which is the blue layer, which is negative 4x. You have to take account into negative sign as well. So, and then this one's negative 40x times 1 minus 2x squared to the 9. Now here's the thing. Can this distribute inside? No. You cannot distribute all the power in 1. You cannot do that. I see somebody try to do that before. It's bad. Bad math. It's like killing a panda.
That's a new one.
And panda is almost 16. So
It should be.
It should be extinct.
what's wrong with you?
That's what Brandon said.
He's not trying to do
If
it.
you put them in the wild, they will. That statement's flawless.
Okay, so shh.
They're a little weird things.
I actually went to when I went to China. I'll show you a video. I went to China. I saw panda. Pretty cool. They're pretty funny. They just eat and sleep.
Have you seen them paint the dogs?
No. All right. So so here we got y. I want you to take a derivative of this function. So y is equal to third roots of 3x minus 6x squared to the second. So I want to take a derivative of this. How would I take a derivative of this? Using the stuff that we learned. I'm gonna write down all the exponent rule for you because sometimes it's very important that you know all the exponent rule. Can you take a derivative of a radical? You can change it to the rational exponents.
I'm not hearing it.
Do you guys convert to rational exponent, which is 2 to the power? Okay, now we're gonna take a derivative.
This is ugly, so I don't know.
It's gonna be 2/3 times 3x minus 6x squared to the negative 1/3. Did you do that? Now also derivative of the inside, which is 3 minus 12x. Now you can have 2 times 3 minus 12x over 3, and then 3x minus 6x squared to the 1/3. Huh? I don't know what? But by more, where?
Distribute the 2 and 3.
You don't need to distribute 2 because it's already in a factor form. You can factor out 3. But you won't want to distribute because it's distributed to make it more complicated. You can factor out 3. So you can even says you can say 6 of 1 minus 4x over 3. Oh, and then they can simplify that further. And that's going to be 2. So it'll be 2 times 1 minus 4x. And this is okay. I don't really need to get you this far. But this is fine, right? So either way, it's fine. I'm okay with here. Did anybody make a mistake here? Raise your hand if you did. Okay. Jesus, I need to know where the mistake you make.
I didn't see that the 3 had an x attached to it.
What?
I didn't see that it was 3x. I thought it was just 3.
3x minus 6x squared?
Yeah, instead of seeing 3x minus 6x squared, I thought it was just 3 minus 6x squared.
Oh, okay. Yeah, Kaden, what did you make a mistake?
What I did is I distributed the 2/3 into 3 minus 12x.
That one is actually okay, but you don't need to distribute ever. because if you distribute, it's actually ruining the. You just make it the inside worse because you have to multiply fractions, and so most you don't want to do that, but it's fine. Anybody else make a different mistake? Everybody okay? All right. Let's talk about when do you avoid quotient rule. When's the situation you avoid quotient rule? So you have polynomial divided by monomial. Right, this has two situations. It has square root x minus 1 over square root x. Let's just say you have this case is polynomial over monomial here. So therefore, it's going to be, well, we can change this to square root x over square root x minus 1 over root x. That's equal to 1 minus x to the negative 1/2. Now I can take a derivative of this. So it's going to be positive 1/2 x to the negative 3/2. And that's answers here. It's going to be just this, right? Very, very simple when you have poly over mod. So second choice, you have polynomial over a constant. Well, polynomial and constants, pretty much constant still monomial. Let's just say y equal to square root of x minus 1 over 2. Technically, can I split this? And can I take a derivative after that? So be 1/2 times 1/2 x to the negative 1/2 and a plus 0. So be 1 over 4 root x. So this will be a derivative of this when you have polynomial over constant. But remember, I said there was a third case. The third case, I show you a different color. What if you have constant over a polynomial? This one I'll only use chain rule. So chain rule. Can you use a product rule? Yeah, but I think chain rule is slightly easier. So imagine you have 2 over 3 minus 2x. If I want to take a derivative of this, how do I take a derivative of this? What's the best way to do this? Yes, Bennett?
F of x is equal to x over 3 minus 2x, and then g of x is equal to 2.
No. Anybody else? Maybe something to do with it, but yes. No. Just don't worry about f of x or 2 over x. Don't worry about f of x or g of x in this case. Just worry about what can I do to make this problem easier where I only can do chain rule. Yes, Armin? Yep. Does that make sense? Now I still have 2 layers, 1 and 2, right? So then y prime equal to 2, 2 still there, times negative 1 times 3 minus 2x to the negative 2 times negative 2, right? So that's equal to 4 over 3 minus 2x to the square. I didn't do a quotient rule, I just do a chain rule. I feel like chain rule is a lot easier. I just move some algebra, take care of algebra situation, and do that. Does that make sense or no? So what if we have this? Okay, what if I want to take a derivative of this? You guys can do this one? There's a constant on the top. It looks like quotient rule. But I can avoid quotient rule here. How do I avoid it? Anytime that you have quotient rule, you should think about, can I avoid it? Go ahead and try it right now. Mm. So check, see if you know your math. As you and your friend get the same answers.
I just memorize it.
In the denominator is that cube square.
Huh?
In the denominator is the cube square.
What do you mean? It's the square root.
Minus 4x cubed.
Yeah, cube.
So healthy though.
6 times -4.
Oh god, no. Give me that.
So it's 12. It's 8. Negative 12 over x.
Okay. I'm just nodding. I don't know. I'm nodding.
Oh, I think
I'm live streaming. So I'm gonna change to negative because it's a denominator. If I change the numerator, it becomes negative. Does that make sense? That's just a negative exponent rule. Now I'm gonna take a derivative of this. There are two layers. First layer here, second layer inside. So that's gonna be -2 in the front, and times -3 over 2 times 3 minus 4x to the -5 over 2. Is that okay? And what's the derivative of the inside? -4. So therefore 2 and 2 cancel. And that's going to be -12. Is that okay? Over 3 minus 4x to the 5 over 2. Because I changed back down to become positive. Is this okay? Everybody is okay? Okay. Now, we already did avoid the thing, so we're going to talk about what's next. Next thing is I want you to find horizontal tangent. Find the x value for the horizontal tangent. X value. Okay, find the x value of the horizontal tangent. In this case, y is equal to 5x minus 2 to the 5th power and 2x minus 3 to the 4th power. And I say, hey, I want to find the x values of the horizontal tangent. Now, do you guys remember how do you find the horizontal tangent? Take a derivative equal to 0. Why? Because when slope is equal to 0, that means there is a horizontal tangent. Something like this. This point here, you have a slope of 0. So at the maximum, minimum, or take a derivative. And if this slope equal to 0, right? So you can actually graph it to decimal to find the answer, but I don't want you to do that. I want you to be able to actually find the answer. So now I have to take a derivative. So f prime of x equal to 0. How do what do I do? I take a derivative of this, set it equal to 0, but the problem is how many rules I have to apply. And how many times. Not only how many rules and how many times. Right? If you want to take a derivative of something times something to the multiple different power. So if I were to take a derivative of this one, what would a derivative look like? Let's start with what kind of rule that you're going to be using.
Okay.
How many rules you had? How many times you have to use that rule?
Two.
So Bennett says what? What Bennett says? No.
No. Hold on.
So Bennett said use chain rule twice. The answer is no. Anything else? McKenna?
Would you use product rule, and then your derivative would be the chain rule for each method?
How many times? Chain rule, how many times you apply?
I guess, like,
Okay, so what McKenna's saying is, yes, there was two things. So I'm gonna use this red box right here to represent this as two functions multiply each other, right? So that's here, and there are two functions multiplied by each other. Is that okay?
Mhm.
Now I'm gonna use a product rule because I have two functions multiply each other. I'm gonna use product rule. But the problem, each parenthesis has other power than one. It has to the fifth power and to the fourth power. So that means I need to use chain rule each time I take a derivative of that particular parenthesis. Does that make sense? So I'm gonna take a derivative of this. It's y prime. And I'm gonna take a derivative of the red. So I'm gonna use red color code. It'll be 5 times 5x minus 2 to the fourth power times what? Times 5, right? See, there's a chain rule, right? And I'm gonna leave the other one alone. So it'll be 2x minus 3 to the fourth. But I only finished one side of product rule. I need to do another side. Am I going too fast? Yes.
The last 5 that you say you multiplied from the front?
No, derivative of the inside of parentheses.
Oh.
So the first 5 is from the power. Second 5 is derivative of the 5x minus 2, which is 5. Plus, the red one is going to be 5x minus 2 to the fifth power. Is that okay? Times derivative of the blue one. What's derivative of the blue one? 4, right? 2x minus 3 to the third power. Is that okay?
multiply that by 2.
Yes. And don't forget the derivative of the inside, which is sometimes, a lot of time, like student does forget. If McKenna didn't remind me, I would have forgot. And I'll be bad. Thank you. Now we're gonna set that equal to 0. Y prime is equal to 0. However, in this particular format, you're not able to find out all the horizontal tangent. What you're gonna do is you're gonna factor out a GCF. Now I'm gonna compare the red one, 5x minus 2 to the fourth power, 5x minus 2 to the fifth power. Which one I should factor out? Which one should factor out?
Minus 2.
To the which power? 4 or 5th? 4. You always factor out the most negative. So in this case, we want to factor out a 4. Is that okay? Because 4 and 5, we're going to come, let's least common denominator. So it's going to be 5x minus 2 to the fourth power. What else? Yeah. So this one is red. And then what? 2x minus 3 to the third power, because this one's the least amount. Now I'm going to put a bracket. Why? Once I factor out, I'm going to have a new parenthesis here. So let's check out the first one. The first one I have 5 times 5 left over. So in this case is a 25 times the 2x minus 3. Does that make sense? Am I going too fast? 5 times 5. Plus, what do you have left? 8 times what? 5x minus 2? To the which power? To the first, right? Because you factor out a 4, you have 1 left. So now I'm going to simplify this. So it's going to be 50x minus 75 plus 40x minus 16. And that's still equal to same. And I'm going to rewrite one more line. And that's going to give you 90x minus, I think it's 91, I'm not sure. It's 91? 75 or 16? So you'll have a horizontal tangent at x equal to 2 over 5. That's to be expected because that's multiplicity. And last one is going to be at 91 over 90. Very close to 1. But you have 1, 2, and 3. So 3 horizontal tangent that you can possibly have. Now this one I for sure put on a test because I want to see if you know how to factor out the most negative. Tomorrow we're going to get to a harder case that you have to factor out the most negative. So this one I'm going to say, hey, can you do this one? And see if you can get done before the class end. At least check each other the derivative.
Mr. Yang,
Mm-hmm.
so when you decided to pull out 5x minus 2 to the fourth power, what did you mean that it was the most negative? Like,
Because to the fourth power and fifth power, fourth is more negative than 5. I'm gonna say most negative because tomorrow we're gonna apply that term, the most negative. Is fifth and fourth. Four is more negative than 5. Tomorrow we're gonna talk about why is I say most negative. I don't say the least amount of power. These sort of make sense because, but when it's something like -2 and -3, I want to factor out -3 rather than -2.
So
Because tomorrow we're gonna get a case where you have negative powers, and you want to factor out the most negative. No, 4 and 3. 3 is more negative.
figure out 4 is only 3. You guys take the lowest number to normal.
Yeah, but when you guys are debating the language, was the most negative or least amount. So I say it's the most negative because tomorrow we're gonna factor out negative powers. So if it's -2 and -3, -3 is more negative.
So red versus blue, right? Yeah. Red, you do the small, you do the
Make sure you do today's homework, Rylan. I already posted, so you have no excuse. Just for you, Rylan. I know today is the day that you're about to skip. I can feel it. Rylan skip once every 2 weeks. So I feel like today is coming up. Okay, so I'm gonna do it on a stream. So
why they call it shade. Oh yeah. Yorktown. Why? Victory and 1781. Not even. I don't know.
That's where I go. No, I don't. No, makes sense.
So weird.
That was the night that I literally took 20 minutes. I was like, I'm rambling when lunch was
I never got into this. You went to
What?
Is it that? I'm kidding. Yeah, but when let's
Let me see it. Is there any opportunity for me to see my test?
I literally can't bring up my glass.
Okay. Is it graded yet? Or-
Some are graded. I'll probably finish grading this afternoon.